Scott Bainbridge from the Australian Institute of Marine Science in Townsville. I want to talk about marine sensor networks and the IoT work, particularly in the context of IMOS, the Integrated Marine Observing System. The next slide, please. So many of you may not have heard of AIMS, or Australian Institute of Marine Science. So we do tropical marine research, basically from the bottom part of Queensland through to the bottom part of WA, up and over the top. Next slide. So AIMS is a part of a thing called IMOS, Integrated Marine Observing System, which is a decade-old program that's been looking at systematic and sustained observing of Australia's marine estate. It works through an implementation model of facilities and nodes. Facilities are technology-based and nodes are geographic-based. And one of those facilities is the wireless sensor networks. Next slide. So you can see down on the right the different facilities within IMOS, and the wireless sensor networks is one that I run. Next slide, please. Okay, so we initially installed it at 7 reefs along the GBR, looking particularly at things like climate change and coral bleaching and so on. What we're really after was the fine-scale, real-time events. We use a mixture of fixed poles and movable buoys. Interestingly, we have two-way full-time communications to all our systems, so we're actually able to talk in our systems in real time, so we can do adaptive sampling, for example. So if a cyclone's coming, we can change the sampling rate and so on. We have been using the Myriota LEO communication system, which is one-way, but a low-cost system as well as things like Iridium and 3G and XG and so on. We look at readings every 10 minutes, and so far we've captured 3 bleaching events and a number of cyclones that have gone through. Importantly, we're able to look at what happens actually on the reef. We have lots of ways of measuring what happens in the waters around them, but at the moment we don't have anything that allows us to get onto the reef and where the corals actually are. Next slide. So, well, this animation didn't work. Underneath this is a picture of Heron Island, which is one of the reefs off Gladstone, and we have a setup there. On the left, you can see one of our buoys, a picture of our buoys with an illustration showing how the sensor's sitting off that. On the right, one of our poles, and in the middle, some of our sensors. The important thing is that our sensors actually get to where the corals actually are. So we're not measuring off the reef or in the water column or somewhere else. We're actually measuring what the corals see themselves. Next slide, please. So we're able to use that data to do things like bleaching dashboards, so develop products. So in this case, we're doing daily averages. We're then contextualizing those against empirical thresholds where we think that bleaching occurs by our empirical data. We also create climatology, so we can identify periods that are unusually warm or cool, and then we can look at anomalies. So this allows us on a daily basis to actually understand what's happening on the reef, and then we can look at responses that are appropriate to what we're seeing. Next slide. We've also been working for port monitoring, so we had a contract to do turbidity monitoring in Darwin Port. Again, we were working with a commercial company in this case to actually look at doing a dynamic system where they would adjust their work schedules based on the tides and the turbidity that we were measuring. And they had a compliance that they needed to work towards, and we actually allowed them to do it within the compliance guidelines, within their timelines, within budget. So the access to real-time data actually changed the way they did their work and actually resulted in a better outcome for everybody. Next slide. So we have a number of areas of expertise at AIMS. Obviously, marine engineering is our main one. So we build things that go in the water and stay in the water. But we have a whole area of electrical engineering. We look at marine sensors, remote communication systems, such as the Myriota, for example. We're moving all our workflows to the cloud, so we'll have end-to-end cloud-based workflows, and of course things like communication products like dashboards, augmented systems, and so on. Next slide. That's me.